a quandary. So,
Hold on, I'm gonna sneeze on you if you get too close. I can listen, I just.
okay, so I have a student who just moved in Monday to Aflac. And Kurt sent me her grades, and her grades are, she had 100 her first 9 weeks and a 65 in the current 9 weeks. So, how are you supposed to enter that if you do total points? Because it like gives you like a little, like if they move in, you know, it gives you like a little thing to enter the input grade on.
The sun thing?
Yeah, I wrote this all down.
Did Allie need something, or is she just being silly? I said hi to y'all this morning.
I wish you would have given, or you would have given her a hard time about not being in class.
Well, I think I went too hard on that on her already, so. Why? I said I think I went too hard on her in that way already.
Oh,
Because she barely talks to me now, so. Okay.
I'm just kidding. There's that reason. I want you, my French teacher. Why is she up here? I don't know why. I mean, maybe some masters.
That's it. Couple more. Okay, well, I know it's the day before break, but we do need to catch up to our my A-Day classes so we're all in the same place. So, we're gonna do basically the same thing we did yesterday. I'm gonna start you off roughly the first half of class before lunch looking at the next topic. And by the way, this is gonna be the last new topic I make you do this semester. So when we come back from break, we will just review the stuff we have done together this semester, and then that should hopefully make it to where you don't have to study outside class for this semester exam. But this last one is on absolute versus conditional convergence. So again, we're gonna have to learn a few rules. We gotta learn how to answer a new question type, but really about 80 to 90% of the work you're gonna be doing is the same stuff we've been doing that we're hopefully getting better at. So, oops, I did that one wrong. There's oh, I'm sorry, I didn't make 2 copies of this. Hold on a second. Y'all been doing any work in your classes yet today?
Yeah.
That's good.
when we turn in corrections, do you want the quiz back too, or just the?
I will need the quiz back too, because I don't know which questions you missed, so. Okay, here we go. Sorry about that. Okay, so the difference between converging absolutely versus converging conditionally versus regular old diverging. Basically what we're going to do, I'm going to try to emphasize the word here, but to converge absolutely, what we will do is we'll take the infinite series given to us, and we'll take the absolute value of the series, and if it converges, then we know the original series also converges, and we'll say that it converges absolutely. But if we try to figure out the convergence based on the absolute value and it does not converge, but the original one does, then it converges conditionally. So if it converges with the absolute value of the series, it converges absolutely. If it does not converge with the absolute value, but the original question converges, we can say it converges conditionally. And then if both of them diverge, we're just going to say that they diverge. So when I say absolute value, of course I'm saying we're taking out all the negative stuff. So in question 3, the absolute value of a sub n, you got to think about what part of this would be negative, and so it would be this negative on the 3. So if I'm thinking about the absolute value, I'm ignoring that piece. And honestly, what I hope is that this converges, because if this converges, then it converges absolutely, because we're testing the convergence of the absolute value sign. If it doesn't converge though, we can still test the original question, which would then be converging conditionally. But if this diverges and the original question diverges, then we just say that it diverges. So again, you have to know that to test convergence for converging absolutely, you need to take the absolute value sign, take out anything that would give you negative terms, and then you need to test this. So this is where we're still building upon the previous things. In my mind, I'm thinking this is not geometric series. The nth term test doesn't really help here because it goes to 0. I can't integrate this, so I can't do the integral test. It's not a p-series, it's not the harmonic series. I can't do those things. You really have to go through your list of things to think about how can I test this. I'm a big fan of, if it's not obviously geometric or p-series or something quick and easy, I'm a big fan of the ratio test. So the ratio test is what we looked at yesterday, and once we introduce this topic, I will ask you to go back and finish up the practice on ratio test. But ratio test is where we took the n+1 term, and then I kind of simplified that. 3 to the n+1 is like 3 to the n times 3 to the first. n+1 factorial is like n+1 times n factorial. Divide it by a sub n. And then you have to remember that this converges if it ends up being less than 1. If it's greater than 1, it diverges, and if it equals 1, then the ratio test was a bad pick. You got to try a different test. So notice I split these up in one step, so that just makes my simplifying a little bit easier. You can see the 3 to the n's cancel, the n factorials cancel, and then you're left with the limit as n goes to infinity of 3 over n+1. And what does that limit go to?
0.
Which is less than. Therefore, it converges. And because the absolute value of a sub n converges, it doesn't just converge, it converges absolutely. Basically what we're saying is we're taking a sub n and we're thinking about if it's always positive. So if you just keep adding those values together, if you add all those values together and it still converges, then if you make some of them negative, you're making that value even smaller, and it's going to converge for sure. The original one will converge for sure. So that's where it gets converges absolutely. So honestly, this is kind of best case scenario. You do the absolute value, you test the convergence, it converges absolutely, and you can be finished. Okay, so now if I do the exact same thing on question 2, again, I want to test absolute convergence first. So absolute value of A, you got to think about what to take away that would sometimes be negative, and you would be left with 1 over n to the 1/3. Okay, so I'm going to hope that the same thing happened in question 2. If the absolute value of A sub n converges, we can say it converges absolutely. That's our answer, and we're done. However, this one is a p-series where p is a third, and so what? What does that mean?
It's less than 1, so it diverges.
Very good. Less than 1, so it diverges. Therefore, it does not converge absolutely, because the absolute value part didn't converge. But it might still converge conditionally. And here's where I said where you want it to be absolute if you're lucky, because converging conditionally takes more work. So just because this absolute value piece didn't converge, the original question might still converge. So then you have to ask yourself basically the same thing. How do I know if this converges or diverges? Well, it's not geometric, it's not a p-series. The only thing that it is it's an alternating series because of this. And an alternating series, we call the stuff that doesn't alternate A sub n. And there's 2 things you had to test for alternating series. You needed to make sure the limit as n goes to infinity of his A sub n goes to 0, which it does. And you need the terms to be getting closer to 0, not just decreasing, because I don't want them to be negative. The absolute value of each term needs to get smaller and smaller and smaller. So I could think about plugging in 1 in for n, I would get 1. I could plug 2 in for n, I would get 1 over the cube root of 2. I could plug in 3 for n, I would get 1 over the cube root of 3, 1 over the cube root of 4. I can see that those are getting smaller. So if both tests of alternating series pass in an alternating series, then the original one converges. But since the absolute didn't work, we can only say this converges conditionally. So converging conditionally means the original question converged, but the absolute value of A sub n did not converge. If the absolute value of A sub n converges, we call it converging absolutely. So again, the difficulty, I mean, yeah, you have to memorize a couple of rules, I guess, but the difficulty of these questions still depends on how comfortable are you with alternating series test, how comfortable are you with p-series test, how long do you have to look at this before you recognize that, etc. All right. Okay, so number 3. So if I want to test absolute convergence, what part of this would be the absolute value of A sub n?
Just n over those 2.
Very good. This is the stuff that would give you negative values, so take it away for absolute value. Okay, does this converge or diverge? It converges? I disagree.
It diverges because of the limit test equals 1, so because it doesn't equal 0.
Right.
Diverges.
So, again, there's not, it's not that you even necessarily have to use this test, but the nth term test is a quick way to test if something diverges. If the limit of A sub n does not equal 0, we know it diverges. So again, when we did the nth term test, I know you guys all did fine with it, and I told you that it's not a problem using the nth term test. None of these are much of a problem when you get to focus on them one at a time. But can you quickly recognize that that's an efficient way to figure out that that diverges, is what you want to keep getting better at. So because the absolute value sign of a sub n did not diverge, it does not converge absolutely, but it still may converge conditionally. So to test if it converges conditionally, you have to test the entire original series, infinite series. This one is an alternating, so you should be trying to apply the alternating series test, where 1, you test the limit as n goes to infinity, and it's supposed to be 0. So the absolute value diverged, a a sub n diverged, so it couldn't converge absolutely. The original question diverges, so it can't converge conditionally. So it just diverges. It never converges. There's no value. It just never converges. That would always go to infinity or negative infinity. Okay, we're still doing okay? Okay, then to try to take that idea one more step further for one more question type here. 4 and 5 have us thinking about what, not just does it converge absolutely or not, but what value of x would make this converge absolutely. So now we've got x's and n's in our question, but we at least know that converging absolutely, it needs to converge for the absolute value sign. So think about what the absolute value of n is. So basically take out the -1 to the n part. And then we have to figure out what value of x makes this converge. Again, if you see an easier way, take the easier way. You're trying to be as efficient as possible. But in this question, I would use the ratio test. So I know that the limit of this, the absolute value of a sub n plus 1, so all these n's become n plus 1s. And now I'm going to divide by a sub n. And in the ratio test, when you divide these have to be less than what to converge? Okay, that's fine. That's what you're going to review here in a few minutes anyway. The ratio test says that if a sub n plus the absolute value of a sub n divided by a sub n, if it's less than 1, it converges. If it's greater than 1, it diverges. And if it's equal to 1, it doesn't help. So I could get some of this stuff to cancel and go away. Now here's what I would it's not required, but I would strongly recommend this on these type of questions. When you've got x's and n's mixed in here and you've got a lot going on, take just a step and do this. Put all the, kind of like group all the n stuff up front, because that's the only thing the limit's going to apply to, because that's the n's things. And then put the rest of the stuff, like the x stuff, in the back. Because then you can focus on the limit piece. The limit of this goes to 1. And since this goes to 1, I really just need to figure out when does the absolute value of x plus 4 over 6, when is it less than 1? And so with the absolute values, x plus 4 over 6 could be less than 1, or it could be greater than -1. Absolute value, you have to split that up. And then finish solving your inequality the way you normally would. Multiply everything by 6. Subtract 4 from everything. Again, it's just like solving an equation. as long as you don't multiply or divide both sides by a negative, and then you should switch the order of the signs. But basically, any number bigger than -10 but less than 2 for x would give you a absolutely converging series. So again, I just leveraged one of my tests, the ratio test. I just started working it out. I said, I know this has to be less than 1 to converge. I did the limit, saw that all this went up to 1, so all the limit stuff basically went away, and then I was left with trying to solve this algebra problem. So this is when it would converge absolutely. Now, it could still converge conditionally at -10 or 2, but you'd have to do extra tests for that. So we'll talk about that in question 5. Question?
Can you pause for a second on this? So I'm just writing it out, please.
Okay, got it. Okay, I started question 5, and it starts off the same way. So if you want to figure out when it converges absolutely, make sure you start off with the absolute value of a sub n. Now I didn't need to take anything out of this because it's always going to be positive. I started doing the limit, or not, the ratio test. Here's a sub n plus 1 divided by a sub n. I know it converges when that limit is less than 1. I grouped all my n stuff together up front because that's the only stuff that you do the limit for, the n things. And the limit as n goes to infinity of this just goes to 1. So 1 times x minus 1 has to be less than 1. And so then I had an inequality. And so if x minus 1 has to be, if the absolute value of x minus 1 has to be less than 1, that means x minus 1 could be less than 1 or greater than -1. Because if it's greater than -1, like 0, the absolute value of 0 is less than 1, so we have to keep it 2. So I started to split that up and then solve normally. We could add 1 to both sides. And so these are the x values that it converges absolutely. Now, I do want to say one more quick thing about this, because you will need this for one of the last questions, and some of you will get there today. My 8A class actually did all of the ratio test and all of this on Wednesday, so it's definitely possible for you guys as well. But these are the times it converges absolutely. But there it could converge conditionally at 0 and 2, so we have to test those independently if we were asked about that. But first, let me make sure that you guys are okay with this. Are you okay with why I said this was the absolute value of a sub n? Okay, are you okay with how I'm setting up the ratio test? Again, you're gonna practice more ratio tests today, so you're gonna get better at that pattern, that process. I told you yesterday when we started that process that similar process will happen several times, so. Okay, I grouped my n stuff up so I could do the limit pretty easily. Oftentimes that really goes to 1 so that this is easy to work with. And then I finished solving, since all this just went to 1, this is the important stuff. And then I solved that. Okay, but let's say you were asked, is it absolutely convergent at x equals 0? No. It's absolutely convergent when x is bigger than 0 or less than 2. But what about at x equals 0 and at x equals 2? It could be conditionally there. So when you need to do that, because again, there is one question that'll ask you about that, even though this one doesn't, so I wanted to squeeze it in here. You can actually test at exactly x equals 0. Take the original question, pull it down, plug in 0. By the way, you're going to need this for another thing we do. I guess we won't get to that till next semester. But if you plug in 0 for x, you are left with this. And does -1 to the n divided by n, does that converge or diverge? Okay. It does converge, so I didn't give you much time because this is the alternating harmonic series. The alternating harmonic series always converges. The harmonic series diverges, but the alternating harmonic series converges. If you don't want to memorize that, then you need to think of this as a alternating series test. The limit as n goes to infinity of 1 over n is 0, like it's supposed to be, and 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, you can see those are approaching 0. So this converges when x equals 0. So even though it's not absolutely convergent at x equals 0, it is conditionally convergent at x equals 0. Likewise, or in addition, I don't know, it depends on the question, but if you wanted to know if x equals 2 was conditionally convergent, take the original question, rewrite it, but instead of saying x, you're going to put a 2, and so you would get 1 to the n over n, but 1 to the n is always going to be what?
1.
So does 1 over n converge or diverge?
It diverges.
So you could say x equals 0 converges conditionally. Between 0 and 2, it converges absolutely. And at x equals 2, it diverges. So occasionally, if you want to actually know a specific x value, you need to plug that x value in, look at the question, and work it as normal. Or plug in 2, plug it into the original question for x, look at the series, and then work it as normal. But again, only do that if you need to. That question didn't say anything about that, but again, they just didn't put an example for that when you need it. Okay, I would like us to look at just a couple of these very quickly, and then if you get to more, that's even better, but I'd like you to practice a couple to get a quick feel and hopefully address some of the things you don't understand quickly. So if you turn the page, do questions 3, 4, and 5, please. Those 3 questions should give you a sample of the 3 different ways these work out. And so I'll give you all 20 minutes. You shouldn't need 20 minutes to do all 3 of these, but I'll give you 20 minutes for all 3 of these. When we come back from lunch, we'll go over these, make sure that you don't have questions from these, and then I'll give you the rest of class to finish up the ratio test from yesterday.
I still have 3 through 20 left on the ratio test.
Okay, well, we'll work on that after lunch, and then if you're still not finished, we'll just see where we're at.
2:42. I don't know why I didn't turn this in before.
Okay,
But
that's fine. Got it. I saw Denny earlier. Also, like I said, we'll go over all three of these when we come back from lunch, but you should be getting 3 different answers for these. That's why I picked these 3 specifically. Should give you a sample of each of the 3 answers you should get. That's fine. Right there.
Thank you. Thank you.
is the absolute value look the exact same? Because I don't see any,
Because the cosine alternates.
So you have to remove the cosine.
Yeah, because if you plug in 1 for n, you get cosine of pi, which is negative, and then if you plug in 2 for n, you get the cosine of 2 pi, which is positive.
So it should be 1 over it.
go ahead and talk about these three that I asked you to specifically do before our break. Make sure that you're on the right track here before we put this aside. And again, these three questions, we should get a sampling of each of the three answers. Now again, I know you're not quite there yet, but honestly, a question like this, I could tell you pretty fast that this converges conditionally, because I can tell that if I did the absolute value of this, it wouldn't have this cosine stuff, which gives you the harmonic series, which definitely diverges. So it does not converge absolutely, but if it's the alternating harmonic series, the alternating harmonic series converges, and so it didn't absolutely converge, I know that it conditionally converges. If you don't take my advice and just memorize that the alternating harmonic series converges, then you have to do the alternating series test. You would have to take the limit as n goes to infinity of a sub n, show that it's 0, and show that as n gets bigger, the absolute value of your terms gets smaller. Both of those happen, so that converges conditionally. Okay, anything specific about number 3? Okay, number 4 then, if I test his absolute convergence, the absolute value of a sub n would be everything except the negative 1 to the n. Now, does this converge? I don't know. Well, actually, okay, I do know now. So, you don't have to FOIL this out, but of course you can if it makes you feel better, if it helps you to see that. I can see that if I was to take the limit of that, I don't get 0, so I know the nth term test tells me that it diverges. So it certainly does not converge absolutely, but it may still converge conditionally. So then you need to test the entire thing, the original question. And so once again, this is a alternating series. I know alternating series is one of our newer tests, but two things have to happen. The limit as n goes to infinity of a sub n has to be 0, but ours is 1. So it does not converge absolutely. It doesn't even converge conditionally. So this one just diverges. Okay, anything else you need to add to number 4? Is that what y'all got? Okay. Okay, and then question 5, then the absolute value of this would be 1 over n to the 5 halves. This is a p-series where p is greater than 1, so this converges. And if the absolute value of a sub n converges, then it converges absolutely. Absolute convergence. So, again, I think you'll have some class time to come back and do a few more of these later, but I do want you to focus on the ratio test first. But what I really need you to, what I need to stick with you here is that yes, you have to memorize the process, test to see if the absolute value of n converges, to know if it absolutely converges. If that diverges, but the original question converges, it converges conditionally, and if they both diverge, it diverges. But truthfully, whether you're going to think this section is easy or not, 100% depends on how good you are at figuring out if those series converge or diverge. So, just like the last 3 questions, if you can quickly see that's a p-series that converges on number 5, then you're done very quickly. If you don't see it as a p-series, or you don't know the p-series test, then you're probably not going to figure it out. Or if you do, you're going to do it in a really tough way. Question 4 and, well, question 3 had a harmonic series and alternating harmonic series, and I memorized both of those, so that's why that was pretty easy for me. And then number 4, the nth term test didn't pass, and the first part of the alternating series test didn't pass. So again, if you feel comfortable with the alternating series, that's not a tall order. But if you feel like you don't know or struggle with the alternating series still, then that's not the new topic, it's the past topic that you still haven't quite mastered. Okay, so if you have some more time to come back to this and work on this, that would be great. Again, I told you my first period, quite a few people actually finished this, turned it in, and finished the ratio test and turned it in. If you don't have that much time, that's okay, but it is certainly possible. So what I would like is number 45, the ratio test turned in before you leave, unless you just run out of time. So if that's the case, talk to me at the end of class, let me see that you work on it, and as long as you use your class time, if you need to finish up for homework, that's fine too. I think it'll go quicker than you expect, perhaps. Again, so when we come back from Thanksgiving break, I'll give you some time to finish up 46 before I expect you to have it done. I'll give you a little more class time and an opportunity to finish it for homework, although you're going to be most familiar with it today because we just talked about it. That's why you might, even if you don't finish it in class, if y'all don't have a lot going on in your other classes, you might want to just get it over with. And then the other thing we'll do after Thanksgiving break is we will review the stuff we did this semester. Some stuff we've reviewed more than others. Like, I think Euler's method was on like 3 different quizzes, so you probably don't need to look that over very much. Improper integrals were pretty tough early in the year, but you guys have been using those, so you're probably not as worried about those as you were at first. But integration by parts has a formula, and if you haven't done an integration by parts in weeks, you may not remember that. So those are the type of things that we will get some practice on, extra practice on, just for the extra practice and double for semester exam review stuff. So, and then when we come back after winter break, we will have just 6 more topics to add, and then we can start looking back, or doing a mixture. We'll do part of we will review a little bit of BC, but also go back and start reviewing some of the AB stuff that we haven't talked about since last year. And then that's when things should start to get a lot easier for you, because we will be done with the new stuff in January, basically. So that gives us a lot of time to get extra practice and get more comfortable at whatever it was you thought was hard, and makes our AP test pretty difficult to not do well.